Hi folks, welcome back to 9.5 matrices and matrix operations. And in this video, we're going to take a look at addition, subtraction, and scalar multiplication, okay? So suppose we have the following matrices. So we have A, we have B, we have C, and we have D. So as a quick review from the last video, let's talk about the dimensions of each of these, okay? So I noticed that A has 2 rows and 2 columns. So A is a 2 by 2 matrix. I can say the same thing about B. I've got 2 rows and 2 columns. So we'll note that B is also a 2 by 2 matrix. Then we'll look at C and D, and we have 3 rows and 2 columns. So this is not a 2 by 3, but a 3 by 2. And same thing for D. We have 3 rows and 2 columns, so 3 by 2. Okay? So compute the following matrix operation. Okay? We're going to take matrices, and it turns out that addition and subtraction and scalar multiplication work exactly as we want them to. Okay? So if we take a look at 2a plus b, here's what that might look like. All right, we've got 2, -2, 3, 0, 1, plus b, which is 8, 1, 5, 4. Okay, so all I've done so far is substitute in the matrices, right? Now, if I have this 2 out in the front, you might be wondering, can I distribute it just like I do with parentheses? And the answer is yes, you can. Okay, this is what we call scalar multiplication. We have the number out front and we just distribute it to all of the entries in there. So that gives us -4, 6, 0, and 2. Plus, we still have our B matrix that we now need to add, okay? It turns out that the way we add, we take the entries in the same spot and we add them together, okay? And same thing here. We would take this entry and add it to this entry. And we would take this entry and add it to this entry. And we would take the 2 and we would add it to the 4 because they're in the same spot, okay? And so if we do our math here, -4 plus 8 is 4, 6 plus 1 is 7, 0 plus 5 is 5, and 2 plus 4 is 6, okay? And so the 6 came from the 2 and the 4, the 5 came from the 0 and the 5, the 7 came from the 6 and the 1, and then 4 came from -4 plus 8, okay? So works exactly like you hope it to. I think the biggest challenge here is making sure that you are adding and subtracting and multiplying your numbers correctly, okay? Great, let's take a look at B. All right, so B says C minus 3D. All right, well, let's copy those down. 2, 1, 1, 6, 0, -3, minus 3 times 3, -2, 1, 5, and -4, 3. Okay, well, I'm going to do the same thing with the 3 that I did with the 2 earlier. So that means I'm going to take the 3 and I'm going to distribute it to all 6 of the entries. So we have 2, 1, 1, 6, 0, -3, minus, let's multiply correctly here, 9, -6, 3, 15, -12, and 9. All right, last but not least, we're going to combine all the terms using subtraction that are in the same spot. So first, we're going to do 2 minus 9, -7. And then 6 minus -6, 12. 1 minus 3 is -2. 0 minus 15 is -15. 1 minus negative 12 is 13, and negative 3 minus 9 is negative 12, all right? So I didn't use colors in the second example, but I feel like we should be able to match those in the same spot, right? So just like we did in A, we do the same thing for B, we just had a different scalar multiplier and we had a subtraction instead of an addition, okay? All right, let's take a look at C plus D, okay? So we're just gonna add C plus D. So we have 2, 1, 1. And we have 6, 0, negative 3. And we're just going to add them to 3, 1, negative 4, and negative 2, 5, 3. Okay. And this one is a little bit more straightforward than the other ones because we don't have to multiply by anything. We just get to add. 2 plus 3 is 5. 6 plus negative 2 is positive 4. 1 plus 1 is 2. 0 plus 5 is 5. 1 plus negative 4 is negative 3. And negative 3 plus 3 is 0. Okay. Now, let's take a look at part D. So part D says D plus C. So instead of C plus D, I have D plus C. So I wonder, before we do D, what are your thoughts? Do you think that we're going to get the same answer that we got in part C? Okay, so do a little silent prediction to yourself. Do you think we're going to get the same order or not? All right, so let's try it out. Let's see if D plus C gives us the same as C plus D. 3, 1, negative 4, negative 2, 5, 3, plus 2, 1, 1, 6, 0, negative 3. All right, let's add. 3 plus 2 is 5. Negative 2 plus 6 is 4. 1 plus 1 is 2. 5 plus 0 is 5. Negative 4 plus 1 is negative 3. And 3 plus negative 3 is 0. So it turns out that when we add matrices, okay, so we can write this note for ourselves. Matrix addition is what we call commutative, okay? Means that the order in which we add doesn't matter. So C plus D is always going to equal D plus C. We don't actually have to do it twice. We can just know that it's commutative, okay? All right, let's take a look at these last two. A minus C. All right, so I'm going to copy down the matrices A and C. Let's plug those in and let's see. So A was negative 2, 3, 0, and 1. And C was 2, 1, 1, 6, 0, negative 3. Okay. So what do we think? Negative 2 minus 2, 3 minus 6, okay, and then 0 minus 1, and 1 minus 0. Well, what about this last row? This last row has nothing to combine. And it turns out that we cannot do this, all right? Matrices are not the same size, so we cannot add or subtract. So in order for us to add or subtract, we need to be able to do exactly like we did in A, which is that everything should color code exactly from one to the other. And if there's some extra ones or fewer ones, then it turns out we can't add or subtract them, okay? So if we had tried to do the color coding here, we could color code those and these and these, and these, but then sort of what do we do with those last ones? Okay, so not the same size, so we cannot add or subtract. We would say this has no solution. Okay, all right. I'm not even going to write down D plus B, but I'm going to go back and say, what are the dimensions? I remember that D is a 3-row and 2-column matrix, and B is a 2 by 2. And since those are not equal, we can say that there's no solution. And I want to clarify here, this is no solution for adding and subtracting, okay? So let's get that all on one page here. Whoops. All right, so adding and subtracting and scalar multiplication. If we want to add or subtract, then we have to make sure that they are the same size, okay? All right, folks, this is it for the second part of the video. In the third part of the video, we're going to get into the juicy part, which is matrix multiplication. All right, so I'll see you back here.